Good evening. I'm your online lecturer, Frank Jacobs. Today we are at chapter 6. We will look at probability. Probability. I would say there's a 99% chance that we'll do probability today in today's class. Right? And off we go. There's some things you need to know. There's some terms you need to know in this road along probability. And this would start with the concept of a random experiment. Random experiment is an action or process that leads to one of several possible outcomes. For example, and the experiments are listed here. You see flipping a coin, this is my favorite one. Flipping a coin, you could get either heads or tails. Those are the outcomes, or the only outcomes that you can get. Exam marks, you could get numbers 0, 1, 2, up to 100. Assembly time, course grades. These are examples of random experiments. The outcomes of a random experiment must be, there's a list of all possible outcomes, and the list must be exhaustive. That is, all possible outcomes should be included. For example, if you roll a die, you not only get 1, 2, 3, 4, but 5. That isn't exhaustive, but to include 6, which is shown here. The list must be mutually exclusive. That is, no two outcomes can occur at the same time. Die roll, you get an odd number or an even number. You cannot get an odd number and an even number at the same time. Getting an odd number excludes getting an even number at the same time in any given roll of the die. Sample space. So the concept of a sample space. A sample space is a list of exhaustive and mutually exclusive outcomes. This is called a sample space and is denoted by S. You could use any other letter, but S is what we normally use. The outcomes are denoted by I1, I2, I3, IK. I subscript I, O subscript I. Use notation from set theory, which is shown here. S is, the sample space is a set of mutually exclusive and exhaustive outcomes. There are some requirements to be met by probability. Given a sample space shown S equals 0, 1 to 0k, the probability assigned to the outcome must satisfy the following requirements. 1. The probability of any outcome is between 0 and 1. Probability can't be greater than 1, can't be less than 0. It's defined between 0 and 1, is shown here for each I. And the sum of the probabilities of all the outcomes must be equal to 1. As shown here, POI1, PO2, right on PO3 must be equal to K. And this is what is shown mathematically here, in the corner here, using the sigma notation. Here we will talk about the approaches to assigning probabilities. There are 3 ways to assign a probability, namely the classical approach, which makes certain assumptions such as equally likely independence about a given situation, relative frequency, assigning probabilities based on experimentation or historical data, and 3, the subjective approach, assigning probabilities based on the assigner's expert judgment, as we say. We look at the classical approach. If an experiment has n possible outcomes, this method would assign a probability of 1 over n to each outcome. Example, rolling a die sample space is shown here. S equals 1, 2, 3, 4, 5, 6, showing all the outcomes, the possible outcomes. Each sample point has a 1 in 6 chance of occurring. There's 6, and using the classical approach, we assign 1 over n, 1 over 6 to each outcome. So the probability of getting a 4 or 3 or 2 or 1 or any outcome is 1 out of 6. Now in the classical approach, again, we looked at the sample space for the outcomes from tossing two dice. You toss 2 dice. These are the outcomes shown in this matrix here. What's in each cell is the total of the total of the face up totals. For instance, 2 would be, 1 is, you have the 2 dice being colored. One is purple dice and the purple die, and the other is the black die. So 2 here really means 1, 1, 1 on the purple die and 1 on the black die. 3 would mean 1 on the purple and 2 on the black die, and 4 would be 1 on the purple and 3, and so on and so forth. So these are actually totals. Those are totals pertaining to the face totals of both dice. Now let's look at calculating the probability, find the probability of getting a 2, getting the up face totals to be 2. That's only one instant where you have, there's a 1 on the purple and a 1 on the black. So the probability of getting 2 is 1 out of 36. There are 36 possible outcomes. There are these outcomes, 36 possible outcomes. To get a 7, how many ways can you get 7 from tossing 2 die? You could have a 1 on the purple and a 6, 1 and 6, 2 and 5, 3 and 4. That is, the 3 is on the purple and the 4 is on the black. 3 and 4. Then 4 and 3, where the 4 now is on the purple and the black is the 3. 4 and 3, 5 and 2. The 5 is on the purple and the 2 is on the black. 5 and 2, 6 and 1. 6 is on the purple and the 1 is on the black. And I think that's exhausted it. That you would notice we have 6 outcomes where you can get 7. There's 6 ways you can get 7. So the probability of getting a 7 is 6 out of 36. 6 ways over total of 36. 10 is obtained the same way. You can get 10 from tossing 2 dice by getting, you can't get a 1 and a 9, there's no such thing, or 2 and an 8. So you start with a 3 or 4. You can start with a 4 to get 10. You start with a 4, 4 and 6. 4 on the purple and 6 on the other. 4 and 6. 5 and 5. 6 and 4. The first number called is on the purple die, and the second number called is on the black die. So here we are. 6 and 4. 4 and 6. 6 and 4. That would be, there are only 3 possible outcomes where you can get 10. So the probability of getting 10 in tossing 2 dice is 3 out of 36. This is still utilizing the classical approach. Now, this is an example using the relative frequency approach. Bits and Bytes computer shop tracks the number of desktop computers it sells over a month, 30 days, over a 30-day period. And this is a table shown here, the number of desktops sold and the number of days you are selling the given number of desktops. For example, the number of days where no computers are sold is only one. It's only 1 day out of 30 days, as shown here, that you sell no computers. 2 days out of 30 you sell one computer. 10 days out of 30 you sell 2 computers. 12 days out of 30 you sell 3 computers, and 5 days out of 30 you sell 4 computers. So with these data, in terms of the number of days where you sell n number of computers, you can calculate the probabilities as shown in this table. As we turn to this actual table shown here, we call that the number of days is 1 day out of 30 you sold no computers. So the probability of selling no computers is in a 30-day period is given by 1 over 30, which is 0.03. And the number of days where you sold only one computer is 2. So 2 out of 30 is 7%, 0.07. And the number of days you sold 2 computers is 10. And so 10 over 30 is going to be 33%, 0.33. That's the probability of selling 2 computers in any given day. When we look here, we notice you have the 12 days where you sold 3 computers. This is the highest frequency you have here, 12 out of 30. That's equivalent to 40%. So this is saying that there is a 40% chance that the company will sell 3 desktops on any given day. So you're more likely to sell 3 computers than any other number within a 30-day period. And this is using the relative frequency approach. As you can see, this is very useful tool to have. The next approach is what we call the subjective approach, or we use the term expert judgment, and so forth. This is based on the knowledge, the expert knowledge of the person who's assigning the probabilities. Here we look at the probability of precipitation, probability defining that there's going to be a shower or rain. This is, as is stated here, this is dependent on different forecasts. It is subjective. It is subjective. But at the same time, this is a very good example, because in this particular case, you get information also from the internet and from the ships. So those are what assist in allow you to forecast, to do your forecast, POP forecast. So it's not really purely subjective, but there's some degree of subjectivity in it. I don't really like the term subjective. I prefer expert judgment, because you become an authority on the subject area. So that is the third means of assigning a probability, called the subjective approach, or expert judgment, as I prefer to use it. When we come to events and probabilities, an individual outcome of a sample space is called a simple event, whereas an event is a collection or set of one or more simple events in a sample space. Let's look at this. If you roll a die, this is the sample space 1, 2, 3, 4, 5, 6, and a simple event would be 3, which is, if you roll, what's probability of getting a 3? It has to be a simple event. And an event would be an even number. An even number will consist of 2, 4, or 6, which is, as you see, 3 simple events. And likewise, an odd number, 1, 3, 5, would also be an event, since it has three simple events, 1, 3, and 5. This is key in here. The probability of an event is the sum of the probabilities of the simple events that constitute the event. Example, assume you have a fair die. S, this is a sample space shown, S equals 1, 2, 3, 4, 5, 6. And P1 means the probability of getting a 1. The probability the outcome would be a 1 is the same as the probability of getting a 2 or 3 or 4 or 5 or 6.